Okay, recording another video, blah, 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 blah. Sorry, can't talk. Okay, recording another video. That's what I meant to say. So we're doing number 9. And I know some have emailed me about asking for help on this, and I think it'll be easier than you thought. So this says on the unit circle, which means it's not one of the points you're familiar with on the unit circle, but it's a point on the unit circle, and we know that because we're told it's a point on the unit circle. It says it corresponds to a real number t given, so that's talking about the angle theta. So I refer to the notes using the unit circle from March 10th. So I'm going to go ahead and switch over so I'm not distracted by having to look at the camera and teach. So these notes, remember we talked about sine being y because it's on a unit circle and the radius is 1. Cosine is x because, again, the radius is 1. And then tangent is y over x, which is sine over cosine. So every coordinate, it's cosine comma sine. So that makes, not that problem, but this problem. So that makes this problem really easy because this problem is on the unit circle. So we know that this is x and this is y. We need to find the 6 trig functions. Let me go ahead and list those real quick. Sine, and then sine is with cosecant, they're reciprocals. This one goes with secant, and this one goes with cotangent. Alright, so that's x, that's y. Sine is y. So remember, cosine and sine are alphabetical order. C comes before S. So this goes with x. And this one goes with y. 3 over 4. That's an easy one. 3 over 4. So when we flip that, 4 over 3. Easy peasy. Flip this, we get 4 over radical 7. We can't do that. So remember, the radical moves upstairs, becomes whole downstairs. Tangent is sine over cosine, and this is where it gets hard. Because sine is 3 over 4, cosine is radical 7 over 4. We can't do that, so we have to adapt. We can't divide by a fraction, so we multiply by the reciprocal. First fraction stays the same. Reciprocal, the second fraction. And the upside of this is we can reduce. Reducing is easy here. So we actually get 3 over radical 7. Radical moves upstairs, becomes whole downstairs. Cotangent, you can flip this and then do all this again, but you don't have to, because you could also flip this and you could flip that. Either one, whatever gives you the easiest answer. This is the one I'm going to flip. There we go. Radical 7 over 3. We don't have to rationalize anything. That one is done. And there we go. Easy peasy problem. Hopefully easier than you thought it was. Now the back side. Okay, let me fix the camera here. Okay. This, also using the unit circle, but these are the specific parts of the unit circle. So here, we actually have to get our unit circle out. So unit circle out. And you know, the upside of taking a test at home is you can use your notes, which means you'll have your unit circle. Hopefully you have it filled out correctly. So here is my unit circle, and the problem is tangent of pi over 6. Tangent pi over 6. So I find pi over 6 is right here. Tangent is going to use this. So I have radical 3 over 2 comma half. Tangents from the previous notes, or what I did on the other side, is y over x. So that is 1 over 2 over radical 3 over 2. Okay, so I think the video is fixed. We can't divide by a fraction, and it looks like I'm out of red lead, so I have to switch colors, sorry. So multiply by the reciprocal. We can reduce, which means we get 1 over radical 3. When we rewrite that with the radical upstairs, we could have 1 radical 3 over 3 or just radical 3 over 3. On the test, I believe I put both answers. 1 with a radical 3 over 3, and then, or just radical 3 over 3. The next problem is sine of 5 pi over 3. So, use my unit circle, find 5 pi over 3. Right here. Here's 5 pi over 3. So that's a positive half and a negative radical 3 over 2. Okay, so positive half, oops, too high, and a negative radical 3 over 2. The beauty of this is it asks for sine, and sine is, remember, y values. So we just need to write negative radical 3 over 2. And we're done with that problem. The next problem. Cosine of 5 pi over 6. So unit circle, find 5 pi over 6 right here. So we have the negative radical 3 over 2 first, and then half. Cosine is a nice one because cosine is the x value. X value is negative radical 3 over 2. And yeah, sometimes we have the same answer twice. It happens. This one, 23 pi over 2. So let's look. Pi over 2, 3 pi over 2. We don't have a 23 pi over 2. So that means we have to, that means it's one of those loopy ones that have rotations. So we have to subtract out rotations. Since this is in radians, our rotations are 2 pi. So we have some work to do for this problem. So 23 pi over 2, you know, I'm going to get a separate paper and use a separate paper. Okay. So we need 23 pi over 2. We need to get something that's actually on the unit circle. We subtract 2 pi. 2 pi over 1. Okay, so write that. We need common denominators. So 23 pi over 2, common denominator, would be 2. So that is subtracting 4 pi over 2. So 23 minus 4 is 19. Let me do this in blue. It's easier to see because I did this on the back of a paper that already has stuff on it. So 23 minus 4 is 19, and then we have pi over 2. Well, that's not on the unit circle. So I take 19 pi over 2, and I subtract 4 pi over 2, which is 2 pi. I subtract 2 pi again, but I already adapted it, so we have common denominators, so I don't need to do that work again. 19 minus 4 is 15. And obviously that's not on the unit circle, so I subtract again. 15 minus 4 is 11. which is, again, not on the unit circle. 11 minus 4 is 7. So we get 7 pi over 2, still not on the unit circle. Three pi over 2 is on the unit circle. So 3 pi over 2 is 0, negative 1. 0, negative 1. Tangent, remember, is sine over cosine. Negative 1 over 0. Well, we can't divide by 0 because we don't know how many zeros it takes to make negative 1. That's not possible. So the actual answer is undefined. It is not 0. 0 zeros do not make a negative 1. The answer is undefined. Okay, so that is the last problem to do for this video. So have a good day.